Assalamualaikum. I'm Iqbal, roll number BCSF 13M038. My topic is architecture of big social networks. First of all, intro this topic. Social networks and community websites became more and more important over the last years. They have really big impact on the daily life of the modern societies. First we'll talk about Twitter. Twitter is an interesting product for analyzing architectural design. Twitter itself is not an open source. There are only spare official information available how the open source component work together in what way they're adapted for the Twitter's need. For that reason, most of the information about the Twitter's internal comes from the Twitter's developer blogs or other community discussions on the internet, where Twitter's main developers deliver insight into why and how architectural designs have been made in the evolution of Twitter. I'm moving fast. Let's talk about the functions of Twitter. There are three main functions of Twitter: is microblogging. The official term for telling what you are doing is called microblogging tweets. The second most important functionality is that of following other users is getting updates with a messaging called tweets. This is basically that the user that you have following, they have posted. This is called the tweets. Search. The third and the most important function is the search function. By using the hashtag functions in tweets, people can get subject to a particular message, where the subject tweets can be made more and more information interesting, and the information becomes available to the user of the Twitter we are following to. Okay, architectural description. Using the view model, there are 5 content views we're going to talk about. Number 1 view is logical view. We can explain it with the help of this using class diagram. You can see this about the users and the properties the user may have. User can get the primary class of the Twitters can data structure are its users. User can create tweets. User can send private message to the users. Users can search anyone using the hashtag, or user can tag anyone. Okay. Next is about the process view. Process view is in terms of communication, and physical view is describe the topology of the Twitter software component and the communication. Development view. Development view illustrates Twitters from a perspective of the developer or a programmer. Scenario view, which is the most important view. You can look at this use case diagram. Scenario view can be explained by a small set of use cases and scenarios, connection between followers, followings, and internet users. You can see the description, and there are 3 actors: users, followers, and the system. Preconditions as users login, user can post a tweets, user can search on words, user can search people, user can follow others, user can have the followers. Non-functional requirements are the availability, performance, and the quality. This is explained in the use case diagram. And moving on to the main description, focusing on the main topic: architectural design of the Twitter beginning in 2006. It was started in 2006. It was as a side product to the employees from the audio company. To do this, they used Ruby on Rails. The choice for the Ruby on Rails was only because the audio company's products website to post a podcast. Okay, audio company website to post podcast was also built on Ruby on Rails. The software engineers had experience with this programming language, and they really liked this tool for make the prototype of Twitter as fast as possible. You can see this. The front-end service was written in Ruby on Rails, and it's provided the communication between the backend service. At the beginning of the Twitter, the backend service was only MySQL database that were used to store all the messages that were being posted. With this architecture, they could easily satisfy the user's most important software quality specs. It can satisfy the quality, performance, and all kinds of specs that they want. Moving on, the next architecture that was updated in 2008 due to the exponential growth in the Twitters. You can see this. There is a new layer implemented. New layer is added. This is called middle layer. Due to exponential growth, this layer is implemented. Basically, this middle layer was also written in Ruby on Rails, and this is basically providing a queuing system in which the tweets could be saved before they were written to the backend. Means when you are writing tweets and you are sending, before moving to the backend service database, MySQL is added in the queue of the middle layer, which is written in the Ruby on Rails. This was the new thing they have implemented in the 2008. And now the time for the front architecture of the Twitter. You can see this. There with the middle layer, a search engine is also implemented. Search engine layer. New search engine recently implemented to speed up the searches dramatically. And using the middle layer as a queuing system, this was basically the best agenda for the Twitter's developers they have achieved. Now I'm going to explain. I'm going to explain the software overlay. First, starting from the end, the backend layer, MySQL and Memcache. This is the backend service layer. Twitter stores all the tweets that are posted by the members. First it was in MySQL, but later, due to several issues, this MySQL was replaced by the Memcache. What is Memcache? You are hoping. Memcache is an open source, high performance, distributed 14 memory objects cache system. Using Memcache, Twitter is able to store all the tweets in memory, making data relatively very fast. You can see the MySQL is still in used. That is just because of backup system, nothing else. And in the current architecture, search engine layer is implemented. This is the written using Apache's Lucene. What is Lucene? Lucene is a high-performance, full-featured text search engine library written entirely in Java. Lucene uses invented index-to-index store tweets. How is it searching? When we're performing a word search, Lucene search for the word request the backend service layer for the corresponding tweets that store the word by using the reference to the tweets and return the received tweets. Means you are posting a tweet using the word request the backend requesting a backend service and giving the words you are searching for. Now time for the middle layer. The middle layer is basically this one is the middle layer. The middle layer is basically using a queuing system to not overload the backend layer service as was discussed before. When they use the no middle layer only SQL for the story, the middle layer was first implemented by using a Starling. Starling which is implemented and programmed in Ruby on Rails, but as this turned out to be slow and unsatisfactory crash recovery. So later replace the Starling component by the three main messaging queues, maybe that could be the JRuby, Scala, and many more like the JRuby. Now the front end layer I have already mentioned the front level services. The front desk for handling all the requests of the Twitter system. All the requests that are handled by the Twitter system come through the front end layer service, which will populate and delegate the requests for the current handling through the whole system. The front end service is built using the Ruby on Rails framework. Ruby on Rails is a framework based on Java, which optimizes program productivity and keeps the program code sustainable. Now I'm going to talk about the architecture of Facebook. Basically, I'm going to compare the architecture of Facebook and the Twitter. What's the difference between them? Facebook, like Twitter-based open software, and like Twitter, Facebook develops and contributes to a lot of the open source software projects. Okay, as Twitter, Facebook is based on the MySQL database. You can see here, which is completely cached in memory by a privately extended version of Memcache. The distributed database Apache Cassandra was developed by the Facebook for private message inbox search and is used for the Twitter as well. And another between them is the fourth group, a lot of smaller self-developed open source projects around the main architecture for doing exactly what they want to do. The biggest difference in Ruby on Rails and Facebook is that Facebook website is PHP implementation and calls itself the second largest PHP website after Yahoo. Instead of developing a messaging queuing system as a Twitter did for speeding up the introduction, Facebook develops a HipHop for the PHP. You can see HipHop for the PHP. It is a compiler which can transform PHP code into C++ code automatically. Using C++ code instead of PHP offers a large performance gains as it works more on the low level base by using HipHop. Front functions can still be written in the PHP. I mean, we have the two functionalities. By using HipHop, the PHP code is completely converted into C++ code automatically. We don't have to do any kind of effort. And by using HipHop, the front-end functions can still be written in the PHP, while the performance advantages C++ are still given. These are the differences I have mentioned. Now, time for the conclusion, what we have concluded in the whole presentation. Conclusion is this: the biggest problem they had to solve was the lack of performance they discovered. While the amount of user increased dramatically, Twitter's architecture changed during Twitter's evolution, and how this evolution was connected with the growth of Twitter's. The reason for not having the two big trade-offs in the system, both has given a major success for Facebook and Twitter's. The example of Facebook shows that assuring scalability is a very important task and is a big challenge for today's big global players on the dynamic social network microblog movement. They're making their way effort. Thank you.